In this video, I'll show you how to use n8n, Home Assistant, and Frigate to create a sound-triggered SOS system, especially for the elderly or those living alone. From any corner of the house, just a single sharp alarm sound triggers an unstoppable response. Remotely, notifications are pushed to family, while nearby, sirens blare continuously to alert neighbors. Alright. First things first, you need something that can produce a sound Frigate can recognize. This could be a simple one-touch alarm button installed in a suitable place in your home, or even a personal safety whistle you can carry with you. With the hardware in place, let's set up the software. The first step is the Frigate configuration. You need to open your Frigate configuration file and enable the alarm sound type that you want to recognize. Additionally, under your camera's roles, you also need to add the audio function. Now, let's start building our n8n workflow. The first node we need is the trigger. In n8n's built-in modules, it doesn't currently support using a Home Assistant sensor's state change as a trigger, so we're choosing a webhook here. You can think of it as a dedicated URL. Any external program or service, like an automation in Home Assistant, which in this project is when Frigate detects an alarm sound, sends a signal to this specific address, thereby starting our entire n8n workflow. Now, let's look at its configuration. First, we set the HTTP method to post. Then, we give it a custom path, which we've named SOS. This generates our final URL. It's this exact address that we will copy and paste into our Home Assistant automation, allowing it to activate this entire emergency response with a single signal. Alright, the moment that webhook receives the emergency signal from Home Assistant, the workflow begins to execute. The signal first arrives at our first action node. This is a call a service node, and I've renamed it Living Room Snapshot. In this project, its task is very clear and critical. The moment it receives the help signal, it immediately commands the living room camera to take a snapshot of the scene. If you have multiple cameras, you could also create multiple branches to achieve this. Now, let's look at its key configuration. First, in the domain, we select Camera. In the service, we select Snapshot, which is the Take a Picture action. Finally, in the service attributes, we define two parameters. The first is file name, where we specify the save path and name for the photo, for example, Living Room Snapshot. The second is entity ID, where we tell it precisely which camera to command, which is security camera. This picture is one of the most important pieces of content we will send to our emergency contacts later. Okay. After the camera has finished taking the snapshot, the workflow proceeds to the next node, Edit Fields. In this project, its task is very specific, to prepare for our repeated notification mechanism. Let's look at its configuration. First, we set the mode to raw JSON. Then, in the JSON output box below, we manually create a data field named loop count and give it a list containing 3 numbers, 1, 2, and 3. The quantity of elements in this list, for demonstration purposes, we've set it to 3, determines how many times our help message will be sent in total. By creating this list, we are telling the system, I want you to repeat the following help message 3 times to ensure the emergency contact can reliably receive it. Now, the signal flows to the next node, Split Out. It can take a list containing multiple elements and then split this list into individual items, outputting them one by one. Let's look at its configuration, which is very simple. In Field to Split Out, we enter Loop Count, which is the name of the data we created in the previous step. In Include, we select No Other Fields to ensure the output data is clean and only contains the split items. After being processed by this node, the originally packaged list of now becomes 3 independent queued data streams. Each data stream will trigger a subsequent loop, which sets up the most critical preparation for the loop node we'll discuss next. Okay, after the split out node has split the data, we now have 3 independent task streams. They next converge into the following node, loop over items. Now, let's look at its key configuration, batch size, which we've set to 1. This setting is key to implementing our multiple interval-based sending feature. It forces the node to process only one task at a time, converting the previous parallel task streams into a serial, ordered loop operation. All right, our loop engine is now running. Each loop will trigger the next node, wait. Its function is extremely simple, to pause the workflow for a period of time. Let's look at its configuration. In amount, we enter 15. In unit, we keep the default seconds. This setting makes the workflow pause for 15 seconds before sending each notification. Without this wait node, the 3 help messages we set up would all be sent out instantly within a few milliseconds, which would bombard the emergency contact with information. Okay, after the 15-second pause, the workflow arrives at the final step inside our loop, which is also the node that ultimately sends the help message. This is an HTTP request node, and I've renamed it Send SOS. In this project, its task is to call Home Assistant's Notify service to send the snapshot of the scene we took earlier along with the help signal as a rich text message to our designated family member's mobile phone. Now, let's look at its key configuration. First, in Method, we select Post. In the URL, we've entered the API address of the Home Assistant Notify service, and it points precisely to the entity ID of an emergency contact's mobile app. Next, we must enable Send Headers and configure the authorization information below. You need to enter your Home Assistant long-lived access token here, which is key to ensuring n8n has permission to call the Home Assistant API. Finally, and most importantly, is the body section. We've constructed a JSON-formatted message that includes 2 core fields: message, which is the help text you want to send, such as SOS, and data, where we've defined an image field whose value is the path where we saved the snapshot at the beginning of the workflow. With this node's configuration, we've successfully packaged the help signal and the scene picture together. At the end of each loop, it will be executed once, faithfully sending this most important information to our emergency contact. Of course, this is just the most basic implementation. You can absolutely run multiple HTTP request nodes in parallel to send to multiple emergency contacts. Even more powerfully, n8n's node library also supports services that can directly send emails and text messages, or even make phone calls. By combining these functions, you can easily create a tiered help system that uses multiple people and different notification methods to ensure the help message is received in a timely manner. All right, we just explained how to loop and send remote notifications to family. Now let's look at the other, equally important parallel branch that leads to this node, Siren on. This is a call-a-service node. Let's look at its configuration, which is very simple. In the domain, we select Siren. In the service, we select Turn On. In the service attributes, we only need to set one parameter, Entity ID, which points precisely to the Siren entity we want to activate, for example, security camera. Its task is to activate the built-in Siren function on the Tuya camera, causing it to emit a piercing, continuous alarm sound. This node is the core of our local help strategy. The loud noise not only serves to deter potential threats, but more importantly, it can immediately attract the attention of neighbors or passers-by, buying precious time for help to arrive. Now, to tie it all together in Home Assistant, you'll create a REST command in your configuration file with the production webhook URL from n8n. Then, create an automation in the UI. The trigger is alarm sound state changing to detected. The action is simply to call the REST command you just made. That's it. Just by pressing the alarm or blowing the whistle at home, the SOS help message will be immediately sent to the emergency contact, and the alarm will also sound immediately and continuously. I've bundled everything from this build into a guide for you. You can find that link waiting in the description. I'm always looking for new ideas, so share what you'd like to build together in the comments. Thanks for watching. Every like and subscribe truly helps the channel expand. Until next time, happy automating.